Chapter 3 is food safety, and this is the second of two chapters for week 2. For this chapter, we will look at food contamination, learn what this is, and then what we can do to prevent food contamination from occurring. There is quite a bit of information available in this chapter, and with that in mind, you can plan on seeing quite a bit of this material on the exam as well. So be able to identify the different major principles of food safety, have a general understanding of the temperatures related to foodborne illness, and know the temperatures associated with the temperature danger zone. Identify the general risk associated with the temperature danger zone. Be able to identify the guidelines for washing hands, and then finally, understand cross-contamination and when foods are at risk for cross-contamination and what risk this poses. Food contamination is a pretty simple concept, and this occurs when something in or on a food causes illness or an adverse health consequence when we consume it. Now there are 3 different types of contaminants. These are microorganisms, physical, and chemical. In this chapter, we will largely focus on contamination via microorganisms, which are related to bacteria and cause illness, but be able to recognize the other types of contaminants. Due to the nature of food, food items are very susceptible to contamination, and food contains water and other conditions and ingredients that are necessary for bacteria to live in and thrive at. This slide lists the different conditions and factors that need to be present for microorganism growth to occur, and these conditions are outlined through the acronym FATTOM, F-A-T-T-O-M. So bacteria, in order to grow and then also to thrive, it needs a food, it needs to be at the correct acidity, there is a certain temperature at which bacteria can live at. The more time that bacteria is at this temperature, the more bacteria growth can occur. It also requires oxygen, and then it also requires moisture or water. So just like us, bacteria require nutrients to live off of, and as we know, food is a source of nutrients. So bacteria will live off of a food source. Again, there is a certain temperature range, or the danger zone, at which microorganisms can grow and multiply. If bacteria is allowed to remain within this temperature range, bacteria will be able to live. And so over time, microorganisms are able to multiply. So the longer the food is within the temperature range at which microorganisms can grow, the risk for contamination of that food increases. Now, because all of these factors are generally present when we eat foods, and to some extent when we handle foods, food is very susceptible to contamination, and contamination can occur very quickly. Again, food contaminants can fall into either physical, chemical, or biological contaminants. Examples of each of these are listed, and be able to recognize the difference between these classifications. So physical is like an object, chemical is generally a cleaning supply, and biological is usually related to some type of specific bacteria or a disease. So foods, again, highly susceptible to contamination. There are many stages at which foods are exposed to temperatures at which bacteria can grow. They are also exposed to oxygen, to moisture, and other conditions that are required for bacterial growth. The quote on the bottom of the page is an estimate and not a perfect representation of reported cases, but it does give us some good information about how prevalent foodborne illnesses really are. Now, it is very difficult to determine whether an illness is related to a specific food or even to food in general, because foodborne illnesses are often not reported. It is also difficult to determine whether a food or specific meal caused an illness, because a person can eat a contaminated food and they will still not show any symptoms of the illness until hours or even days after eating this food. This slide is especially important because there are many opportunities for contamination to occur in the kitchen, which is where you are going to be working for a significant portion of this class. People that are working in the kitchen can very easily carry pathogens on their skin or clothing, and any physical surface can contain microorganisms, and therefore you must wash your hands or change your gloves after touching a new object or surface that is not clean. Now keep in mind that these surfaces could include the handle of the refrigerator, a microwave, counter, or any number of other items. Through cross-contamination or touching of a contaminated surface and then working with food that you are going to eat, one can very easily spread microorganisms to other food. And even if a surface appears clean, such as a tabletop, such as a handle, there is a very strong chance that if it comes in contact with people quite frequently, then there are going to be many, many microorganisms that have developed and that do live on these surfaces and that can be very, very easily transferred to other food. And we'll touch more on this topic a little bit later in this chapter. Now, if foods are not cooked to proper temperatures, pathogens can still survive. Undercooked meat is especially susceptible to contamination. Improper storage and refrigeration conditions and temperatures are also strongly linked to food-borne illness. If foods are not stored properly and temperatures and other conditions are at levels that are conducive to pathogen development, there is a significantly greater chance for contamination. Take a look at the graph on the right-hand side and consider the prevalence of severe food-borne illnesses in the United States. Note that the bacteria listed does not include all types of food-borne illnesses. These are just some of the food-borne illnesses with more severe consequences. Now note that all states except 4 have had reported outbreaks over the course of 1 year. Remember again that many outbreaks are not reported, and some states are much better at reporting these outbreaks than others. There is a very strong chance that Arkansas, Kentucky, Montana, and Vermont all had outbreaks of these food-borne illnesses. This slide looks at the amount of time that it takes for a food-borne illness to enter our system and then reach levels that will actually cause physical symptoms. Now, you do not need to memorize the time that it takes for this to happen, but what you should be able to recognize from this slide is that it can take a very long time after eating a contaminated food before a person begins to experience its associated symptoms. This can take hours and in many cases even days, so it takes a very long time in some cases for food-borne illnesses to enter our system and then to show symptoms. So again, this shows that it's very, very difficult to link our symptoms or any specific illness back to a food simply due to the length of time that it takes for these food-borne illnesses to develop in our body. E. coli and Salmonella are 2 of the most severe food-borne illnesses that we know of. Now, between the 2, E. coli is typically related to slightly more severe gastrointestinal complications. Gastrointestinal, gastro means stomach, intestine means the intestines, so the connection between the stomach and the intestines. And these complications related to E. coli include blood in stools. Now, both of these foodborne illnesses are related to undercooked meats and food handlers' improper hand washing techniques after using the bathroom. Note that for both of these are related again to very, very severe digestive complications, and they are also related to undercooked meats. These are the general guidelines for food safety in the kitchen. Now look at this list. There are 5 different topics. How complicated is this? It really is pretty simple, but nevertheless we still tend to see a very high prevalence of various foodborne illnesses, not only in our homes, but also in various food service establishments. So following these guidelines very stringently is very important to preventing foodborne illness, mainly because it is just so easy for foods to become contaminated. Now, if you do follow these foodborne practices, if you follow these food safety practices, it is very, very difficult for pathogens to survive and then also to grow and multiply. So by washing hands, by cleaning all surfaces that you are working with, preventing cross-contamination, cooking to correct temperatures, and then refrigerating at correct temperatures, by doing all of these things, you limit the chance for bacteria to survive, to grow, and you also increase the likelihood that you are going to be eating very, very safe foods. There are many, many outbreaks that have caused hundreds, thousands, tens of thousands of people to become sick from a certain food or from a commercial establishment because a person that was handling the food did not do a good job of washing their hands. So be very aware that hand washing is crucial towards preventing foodborne illness. And whenever you are touching any surface before touching foods or working with one food that might have some contaminants on it, and then going to another food that's ready to eat, you need to be washing your hands. And this slide outlines how you can do that effectively to kill all of the microorganisms that could be present on your hands. So the main guidelines that we'll highlight: you should be using a liquid soap and not a bar of soap, and you should also be using soap as opposed to sanitizer. Now, if you want to use sanitizer in addition to soap, that's okay, but you have to at least use soap, because sanitizer by itself is not sufficient to kill all germs and remove any potential particles or physical contaminants that may be present on your hands. On the third step, note that you should be washing your hands thoroughly with the soap for a full 20 seconds. And when you're doing this, you should be getting both sides of the hands. You should be getting under the fingernails, basically every single location of the hand, because any of these locations can very easily come in contact with one another, and they can also very easily come in contact with the food. So 20 seconds and get all areas of the hand, and even under the nails and in some of the areas that are more difficult to reach. Rinse your hands, dry your hands, turn off the tap, and notice for number 6 what that person is doing. They have their hand on either a towel or a rag or a paper towel, and they are touching that to the actual surface of the handle that turns off the water. Now, if they go to turn that off with their hand, remember that they turned that on before they washed their hands, so their hands were still dirty at that point. There's also probably many other people that have done the same thing. So there's a very good chance that there are tons of microorganisms on that handle, and by putting a physical cover, in this case the towel or the paper towel, they're allowing their hands to stay free of a potentially contaminated surface. So if you wash your hands and then you turn off the faucet with your hands that are just now clean, you may get your hands dirty. You may have completely defeated the purpose of washing your hands in the first place. Understand what cross-contamination means and be able to provide an example. So cross-contamination, this is always related to one food, one surface, or one object that contaminates another food that is originally not contaminated. This contamination frequently occurs from the spread of microorganisms from raw meat to ready-to-eat foods. So let's say you're preparing a chicken salad. Now, if you're making a chicken salad, you have to cook the chicken, but the other ingredients, such as the mayonnaise, the celery, onions, black pepper, etc., they only have to be cut or simply just added to the foods, and they do not have to be cooked. These ingredients, the mayonnaise, celery, onions, black pepper, those are all ready-to-eat foods. Now, say you cut that raw chicken up into cubes on a cutting board. You throw this chicken into the pan, and then you use the same cutting board to cut the onions and celery, which makes perfect sense because you do not want to dirty a lot of dishes. Well, you have all of the juice from the raw chicken on that cutting board. And as we know, raw chicken, raw meats are very, very susceptible to bacterial contamination. And so that surface, because it has the juice that was in the chicken, that juice is loaded with different bacteria and microorganisms. So when you chop up the celery and onion within that juice on that same cutting board that you cut up the chicken with, that celery and onion is going to pick up the bacteria from the uncooked chicken. So then you put the cooked chicken into the pan with the celery, with the mayonnaise, with the onions, and the celery and the onions that are now contaminated with the original juice from the uncooked chicken, even now that the chicken is fully cooked and the bacteria in the chicken has been destroyed, that entire food still has the microorganisms from that original uncooked chicken, and the food, the chicken salad that you're now eating, is now very, very contaminated. Now, to prevent this, you can do either one of two things. You can either wash the cutting board after preparing the uncooked meats, or, which is the second option, which is probably a much better option, or you can use an entirely separate cutting board for foods that still need to be cooked and foods that are ready to eat. And this method, again, is very, very effective for reducing the risk of food contamination. And you'll notice in the picture, all of these cutting boards are of different color. Sometimes as simple as that, something as simple as that is very effective at helping you to remember to separate the raw meats from other foods and foods that still need to be cooked from the ready-to-eat foods. When cooking and storing foods, the foods that are being prepared should be brought to temperatures that are not conducive for bacterial growth. The danger zone is 40 to 140 degrees Fahrenheit, and within this danger zone, microorganisms can survive and even multiply. If the temperature is from 33 to 40 degrees, microorganisms can still grow, but they grow at a very, very slow rate, simply because it's too cold for them to grow at a very quick rate. Once you go below 32 degrees, bacteria will actually freeze and bacterial growth will completely stop. So if you'll notice that if you put bacteria in the freezer, it stays fresh and maintains a higher quality for a very, very long period of time. If you put it in the refrigerator, it maintains a high quality for a much longer time than if you were to leave it out on the counter, which is going to be in room temperature. But this is still going to be better than just leaving it out. If the temperature is above 140 degrees, bacteria cannot survive and they will actually die. So the main ranges to understand: 32 degrees and below, bacteria does not grow, but it can come alive once temperature increases. 33 to 40 degrees, bacteria can grow, but at a very slow rate, so it's considered generally safe for storage. 40 to 140, bacteria grows at a rapid rate, and then above 140 degrees, bacteria simply dies. And as you'll see, above 140 degrees, you have the required internal cooking temperatures for certain foods, and that is at that number, a number that's above 140 degrees, because that number kills the bacteria that are in that food.